Hi everybody, in this video we're going to take a look at the XY plotting feature in JMP and look at some of the more sophisticated things that it can do. So we're going to go to Analyze, Fit Y by X, and again, as in a prior video, we're looking at literacy rates versus average years of education. So here's the XY plot we've made before, and here we're just focusing on data from the United States. I'll expand this. In an earlier video, we looked at a linear plot, and then we looked at making a quadratic by going to this little downward pointing red arrow, and we could hit polynomial, quadratic, or cubic, or quartic, or something like that. What I want to do is look at a couple of other things that we can do that are a little more sophisticated. Let's say you believe that for average years of education, that if that is zero, that literacy should also be zero. If we put a line through this data, let's double click on the horizontal axis. It's stopping at 4. Let's take it all the way down to 0. And let's take literacy and take it down to, let's say, 50%. And you could see that the intercept, as we saw before, the y-intercept, the zero-intercept, is about 65%. 64.95 is what we get out of the linear model. Is it possible that with an average number of years of education at 0, that we would really have 65% of our population be still literate? You could see a little bit of curvature here, and you might imagine that the curvature would continue to the point where, let's take this all the way down to 0. Is it possible that if we had 0 years of education, we may have 0 literacy rates? Well, we could play around with the linear model. What I'll do is I'll erase, well, no, we'll keep that model there. We could fit a line, but we'll do, oh, I forgot to pick something special. What we're going to do is go to fit special instead of fit line. We'll do no transformation, which means that it's linear, but we'll constrain the intercept to 0. That'll force the line to go through the 0 intercept. So you could see we have some competing problems here. This blue line fits those data really well, but it tells us that with 0 years of education, we'll still have an average literacy rate of 65%. That might be true if people are self-educated, but maybe we don't believe that. Maybe we think it'll be closer to 0. But if we force the line through 0, now we don't explain that variation very well. So let's get rid of both of those curves and look at some possibilities for explaining the data that gives us a curve that comes closer to this value. And then it just depends on how well we want to fit it. So we're going to go to fit special for our options. We could try a 1 over x curve. That actually does really nice job of fitting the data. It might come down too steeply. It says even after an average education of over a year, you'd still have 0 literacy. Do we believe that? Well, maybe we do. Here's the equation, and we can put it into Excel if we wanted to. So this says literacy is equal to 114 minus 148 times the reciprocal of y. Let's take a look at how that translates into Excel. So I'm going to copy that equation, and we'll go over to our Excel sheet, and I'll type it in here. So there's our reciprocal of y. What does that mean? Let's interpret that. So this is literacy as a reciprocal, or 1 over. What that means, if we want to enter this equation, it is equals 114.00555 minus 148.78257 times the reciprocal is 1 over ay. So that's what our equation is. And as you could see from our chart here, as this line goes plunging downwards, its y-intercept will be at some negative value. So we should not be surprised if we have a negative value here. Let's push this up to a larger value. So let's go ahead and fill down. I've changed the 0. Let's make it a half a year. We're at minus 183. Well, that doesn't make a lot of sense. But if we get up to higher levels of education, we might be able to do a better job of fitting the curve. Let's do a Command-Shift copy, and we'll plot that in here. Oh, it looks like I've already set it up so it would be plotted. So that's our curve right here. That's our reciprocal curve being plotted against our linear and the quadratic model that we showed earlier. By the way, in an earlier video, I had trouble plotting the data of AY versus literacy. That's because I had literacy over here to the left of AY. I've shifted it to the right. In Excel, if I pick two columns, the left column is always the X, and this will be the Y. And I had literacy as the X when I really want literacy on the Y value. So I'm going to select these two columns. Hopefully this will be a little bit better. And we'll go to Edit, Paste Special, and hopefully now we'll have some points that will appear in the plot. We're still having trouble. We're not going to deal with that any further. All right, so let's look at how to create one more kind of plot that will maybe explain this data a little bit better. I don't mind that 1 over x, but I'm going to go ahead and remove it. Let's try a fit special, but we're going to do a natural log. We'll make it quadratic, and we'll constrain the intercept to 0. So it doesn't extrapolate it all the way to 0, but we get a nice fit of these data, and we get this curvature. Where does that curvature go? It's not showing us, but if we import this into Excel, we can go ahead and plot it up and see what it looks like. So let's change this to a 24 so we can read it. So here, this is literacy, but we have a quadratic natural log equation that we're going to plot. Let's take a look at how to read this. So this is what we saw in Excel. I'll put it in red font so it's a little bit easier to see in all this mess that we're building. So if we want to enter this equation, this is what JMP gave us. It is equal to 0. There's no intercept. 73.948529 times. It says log, but we chose natural log, so that's log to the base e. In Excel, that's ln, and it's the natural log of average years of literacy. And then we're going to subtract 13.47735 times. This is the log squared, so we'll take inside the parentheses the natural log of AY, and that entire thing is being squared. So we'll close the parentheses on the natural log and write root 2, and we get a minus 57, a smaller negative value than we get for the reciprocal. And so we'll plot this curve, edit copy, and edit paste special. And there's the full curve. It looks actually pretty close to the reciprocal, so maybe we don't get much improvement. We get smaller negative values, but it's still heading to negative values, even if we have a little bit of education added into our model. So you could play around with things like this. I'm going to try a cubic just for fun. That didn't work at all. Polynomial, quadratic. A quadratic actually does pretty well, but it gives us a much lower intercept. But we can play games here, finding paste special, maybe with the natural log. We don't want to constrain it to 0. We'll let it be quadratic and see if that fits. Oh, it actually kind of mimics the quadratic a little bit. We could try a paste special, natural log, maybe cubic. What does that do? That doesn't really improve the fit very much. But we could play games in this paste special by transforming any of these fellows into quadratic or cubic or quartic. We can try a reciprocal in a quadratic function. We can constrain the intercept to 0 if we think it should be. Oh, that's really not a bad job. Actually, it probably gives us a little bit too much of a curvature, but it does give us the 0 intercept that we wanted. So you could play games like this And if you get an incomplete function, it's always nice to import these things back into Excel so you can see the full range of values being plotted out.